All right, so now I want to show you how to solve. We've been solving equations primarily. I want to show you now how to solve inequalities. And the method is very, very similar. Uh, as it says here, the first strategy is we solve as we would a normal equation. The only difference is that we're going to have to test some values out at the end on a number line. And here's part of the reason why. First of all, it's an inequality, so the solution to equation is something like x equals 2. The solution to inequality is something like x is less than 2 or x is greater than 2. So that means there's many possible answers that would fit that. So we're going to have to test that at the end. So let's start by multiplying everything by the least common multiple. And in this case, the least common denominator means the same thing. We're going to need a 3 to cover that. Okay, so the 3 will cover the x plus 3 part. We'll need a 4 to cover this right here. So 3 times 4 times, and then we're going to need an x minus 2 as well. So that's our least common multiple. So I'm just going to do 3 times 4 times x minus 2 right here. Of course, you could multiply 3 times 4 to get 12, but it's probably easier to just keep it as 3 times 4 for now. All right, so now we are ready to distribute. So the 4 will cancel here, and we're going to be left with x plus 1 times 3 times x minus 2. So x plus 1 times x minus 2, and then I'm just going to put the 3 in front, and we're still facing. And by the way, here's why we're going to have to change it. You might remember that when we're solving inequalities, if we multiply or divide by a negative number, we have to flip the sign, and we don't know what we just multiplied by. We know 3 and 4 are positive, but we don't know what x equals yet. X might be something that's a negative number. So this is why the second part of the strategy up here says we're going to have to test things out at the end, which we'll get to shortly. All right, now over here, when we distribute, let's distribute to the far one first. So the x minus 2's will cancel, and I'm left with 3 times 4 times the 1. So 3 times 4 is 12, times 1 would be 12. We still have this minus right here, so I'm going to put a minus. And then when we distribute to this thing right here, the 3's will cancel, and we're going to have 4 times x minus 2 times x. So 4 times x minus 2 times that x. Okay, now we're in a position to be able to clean this up. So if we distribute, this is going to be 4x minus 8, and then times that x is going to be 4x squared minus 8x minus 12 is less than, right here when we FOIL this, it's going to be x squared. The outside terms will be minus 2x, inside will be plus 1x, and then 1 times negative 2 is minus 2. And then we still have that 3. Okay, so let's simplify that. So 3 times x squared is 3x squared. Negative 2x plus x is negative x, and we multiply that by 3, we get negative 3x. And then 3 times that negative 2 is negative 6. Okay, now we have a quadratic equation. We know how to solve those. We need to put that in standard form. Or I shouldn't say an equation. We have an inequality. So we'll move everything to the other side so that it's going to be, we'll be dealing with 0 in that case. And then we can see if maybe we can factor. So we'll add 6 to both sides here. So 4x squared minus 3x squared is x squared. Negative 8x plus 3x is negative 5x. Negative 12 plus 6 is negative 6. Does this factor? And the answer is yes, it does. What numbers multiply to negative 6 but add to negative 5? So that's going to be, well, these both have to be x's. I think it would be x minus 6, x plus 1. So now let's solve this. So our key values, what we would call the critical values, are going to be, even though this is less than 0, we want to know when it equals 0. This one equals 0 at negative 1. This one equals 0 at positive 6. And then up above, we have something called an excluded value. I'm just abbreviating that, like you see right there, exclude val. And the excluded value is what's going to make that thing equal 0, because we're not allowed to have zeros in the denominator. What would make x minus 2 equals 0? And the answer is x equals 2. So we now have 3 what we would call critical values. We have negative 1, positive 6. That's what's solving this equation right here. And then we have 2, which would make the original one 0. So if this were an equation, we would pretty much stop right at negative 1 and 6. But what we need to do, like it says here, make a number line with the solutions and then plug in numbers to test what works. Okay, so I'm just going to clear this off. Let's remember our solutions. We have 6, 2, and negative 1. So remember those numbers, 6, 2, and negative 1. So we have more space here. So I'm going to put those on a number line. 6 goes here, 2 goes here, negative 1 here. And then we basically get kind of 3 regions right here. Actually, we get 4 regions. I'll number them for us. We have region 1 is after -1. Region 2 is in between those. Region 3 is here. Region 4 is here. So all we need to do is pick a test point in each region and plug it in to this and see what the result is, whether it's true or not. So let's let's do that right here. So let's decide. I'm just going to decide a test. We need something in this region. By the way, these should all be unshaded because this original is x is less than, not less than or equal to. So I'm going to pick something that's to the left of -1. Let's just pick -2. Okay, so let's plug in -2 right here. So -2 over 3 minus 1 over -2 minus 2 is -4. And then if we plug in -2 here, -2 plus 1 is -1 over 4. So we basically want to see if this is true, because if it is true, we're going to include it in our solutions. If it's false, we're not. So if 3 and 4 have a common denominator of 12, so -2 over 3 is like -8 over 12. And by the way, this minus minus right here, we can change that to plus. Okay, and then 1 over 4 is the same as 3 over 12. So this becomes -5 over 12 is less than. Let's change that into, if we multiply the top and bottom by 3, that's -3/12. Question is this true right here? Is -3/12 greater than -5/12? And the answer is yes, it is. It is greater. So we're going to include this in our shaded region. This is part of what solves this for us, because we got something true. All right, now let's test the next one. We need a number in between -1 and 2. The easiest to use there would be 0. 0 is always very easy to plug in. So let's let's plug in x equals 0 to this. So the first one will be 0 over 3. Plug in 0 there, minus 1 over -2. So that's the same as 0. Minus minus is like plus, so 0 plus a half, which is a half. And then it's less than, if we plug in 0 here, we get 0 plus 1 over 4 is 1/4. So the question is this true? Is 1/2 less than 1/4? And that's wrong. That's false. So this is not part of our solution region. All right, now let's test a value in this region. So between 2 and 6, let's just take 3. By the way, you can pick any number in that region. They'll all give you the same result, as to whether it's true or false. So let's plug in 3 here and here and here. So 3 over 3 minus 1 over 3 minus 2 is less than 3 plus 1 over 4. 3 over 3 is 1. 3 minus 2 is 1. So 1 minus 1. Is that less than 3 plus 1 is 4 over 4, which is 1. So 1 minus 1, is that less than 1? No, it's not. I'm sorry, I misspoke completely. 1 minus 1, is that less than 1? Yes, it is, because 1 minus 1 is 0. 0 is less than 1, so we're going to shade in this part right here. Okay. Last region, we need a number bigger than 6. Why not try 7? Again, you can try any number you want. I'm just using 7. Actually, you know what? Instead of using 7, I'm going to use 9, and I'll tell you why. I look over here and I see that I'm going to have to put 7 in here. I'm going to have to divide the x by 3. 7's not easy to divide by 3, but 9 is. So let's use 9 instead. So we have 9 over 3 minus 1 over 9 minus 2. Is that going to be less than 9 plus 1 over 4? So 9 over 3 is 3, minus this thing becomes 1/7. So 3 minus 1/7 is 2 and 6/7. And 9 plus 1 over 4, that's 10 over 4. And 10 over 4 is 2.5, or 2.5. So this number is actually bigger than 2.5, not smaller. So this is not part of our region. So how do you write your final answer here? Your final answer can be written as follows. You can write that as x is less than -2, okay, or x is between 2 and 6. So 2 is less than x, which is less than 6. And that's how we can write that answer. That would be the solution to that inequality. So you have multiple regions where this could be true. We plugged in numbers, and when we did that, the only places that got us a true value were the ones that we just found there. Okay, so that's, by the way, what we did there is essentially we found, actually, I'm sorry, I don't know why I said -2 here. That should be -1. This is a -1 right here, but that's how we'd write the solution.